Hello students, welcome to my channel. In this class I am going to teach you mathematical induction. So let us solve a problem using mathematical induction. Now the problem is proof 1 by 1 into 2 plus 1 by 2 into 3 plus plus 1 by n into n plus 1 is equal to n by n plus 1. Let Pn this represent the entire statement. That means Pn stands for 1 by 1 into 2 plus 1 by 2 into 3 plus plus 1 by n into n plus 1 is equal to n by n plus 1. So, in order to prove this problem by using principle of mathematical induction, we have to establish this statement for n is equal to 1. So, this is first step. For n is equal to 1, left hand side, we will take the first term of the left hand side. This is 1 by 1 into 2. This is equals to 1 by 2. Now the right hand side, taking n is equal to 1, it will be 1 by 1 plus 1. This is 1 by 2. So what we get? Left hand side is equal to right hand side, implies P1 is true. So the first step is over for this problem, and we have established here for n is equal to 1, the left hand side of the expression is equal to right hand side of the expression. Now second step. Let Pn be true when n is equal to k. Let Pn be true when n is equal to k. So we can write Pk stands for 1 by 1 into 2 plus 1 by 2 into 3 plus plus 1 by k into k plus 1 is equal to k by k plus 1. So here let us take this as equation 1, and we have assumed here Pk is true. Third step. In this step, we have to prove Pk plus 1 is true whenever Pk is true. To prove Pk plus 1 is true, when Pk is true. Now Pk plus 1, this stands for 1 by 1 into 2 plus 1 by 2 into 3 plus plus 1 by k into k plus 1 plus 1 by k plus 1 into k plus 2. So now this is equals to the expression starting from beginning up to 1 by k into k plus 1. Using this equation 1 equals to k by k plus 1. And the last term of this expression is 1 by k plus 1 into k plus 2. So this expression, starting from beginning to this is k by k plus 1. And we have taken this value here. The last term is 1 by k plus 1 into k plus 2. Now adding this to expression. Here LCM is k plus 1 into k plus 2. So now this is k into k plus 2 plus 1, which is equals to k square plus 2k plus 1 by k plus 1 into k plus 2. This is equals to k plus 1 whole square by k plus 1 into k plus 2. And again this is equals to k plus 1 by k plus 2. Can be written as k plus 1 by k plus 1 plus 1. So in place of n, we are getting k plus 1 by k plus 1 plus 1. What this shows? This shows that pk plus 1 is true. Hence, Pn is true for all n by mathematical induction. So in this step, we have proved pk plus 1 is true whenever it is true for pk. And we get the expression is equal to k plus 1 by k plus 1 plus 1. That means in place of n we are getting k plus 1. This so that pk plus 1 is true. So by principle of mathematical induction, Pn is true for all n. So the problem is solved. The topic for today class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.